We haven't talked yet about the oblique asymptote other than in passing and saying it's a slanted asymptote. So let's do an example that has a slanted asymptote, an oblique asymptote here. This is example 4 on page 483. F of x equals x squared plus 4 over x minus 2. Now, just because it's an oblique asymptote doesn't change any of the steps. So let's run the steps here. Step number 1, the vertical asymptote. Where does the denominator equal 0? In our case, x equals 2. That's where that happens at. So we have one vertical asymptote at x equals 2. Next comes the horizontal asymptote, or what we think is the horizontal asymptote. We take the top value from the numerator, x squared. We take the top value from the denominator, x. And we say, all right, let's assess. This time, numerator beats denominator by exactly 1. Because remember, this x means x to the first power. If you need to put that in there to remind yourself, go ahead and do that. And 2 is greater than 1 by a factor of 1. So this doesn't have a horizontal asymptote. This has what's called an oblique asymptote. Now, an oblique asymptote is also a line. It's just a slanted line. So to figure out what the equation for that line is, we have to synthetically divide the denominator into the numerator. So we're going to take 2, because remember when we talked about synthetic division, just because it says x minus 2 doesn't mean we're going to use negative 2. We're going to use the opposite value, unless they tell us to do 2, and then we're going to do 2 and not do the opposite value. We have 1 x squared in the house. We have no x's, and we have a 4. Remember, there should always be one more value in the house than the power. So our power is 2. We should have 3 values in the house, which we now do. Draw the line. Do your synthetic division. 1 comes down. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. And 4 plus 4 is 8. This 8 is a remainder. We don't really need it, though. What we need is the first two things, which tell us that x plus 2 is the equation for the oblique asymptote. All right, step number 3, the y-intercept. What happens when x equals 0? So we're going to get 4 in the numerator. We're going to get negative 2 in the denominator, which gives us a grand total of negative 2. Make sure you write that the right way, though. 0, negative 2. For the number 4, it's the x-intercept. And the x-intercept happens where the numerator equals 0. So x squared plus 4 equals 0, which means that x squared equals negative 4. And we've got a bit of a problem here, because while we could solve this by taking the square root of both sides, that would give us a negative 4 in the square root. So algebraically, it would tell us that the answer is plus or minus 2i. But graphically speaking, that means it doesn't have a x-intercept. So we can say here's no x-intercept. And then the great thing about having no x-intercept also means it doesn't have a weak point, because oblique asymptotes don't have weak points. So step 5 is just not needed here. It's only needed if we have a horizontal asymptote. All right, so we're ready to rock and roll. Let's go ahead and draw our Cartesian coordinate system in here and put in what we know. All right, we know that there's a vertical asymptote here at positive 2. So let's call this positive 2 here, and let's draw in our vertical asymptote. It's important to draw those in. You know, in some math classes and things, they don't want you to draw the asymptotes in. I do. Always draw in your asymptotes, please. Next comes the oblique asymptote. It has a value of x plus 2. So let's do a couple of points here so we can draw this line accurately. So if it is x plus 2, and we do an x, y scale, and if I put 0 in for x, I'm going to get 2. So that's one of the points on our oblique asymptote. And if I put in negative 2, I'm going to get 0. So those are our two intercepts really on our oblique asymptote. So 0, 2. So let's call this 2 right here. That's kind of a point we're going to, just a little hash mark there, because it's not really a point. It's a point we're going to use for our oblique asymptote, but it's not a point on the graph. And then negative 2, 0. So then 1, negative 2 right about there. Put a little mark there. And then we're going to connect those with a dashed or dotted line. And if we miss it, that's all right. We're close enough. Okay, so now comes the point that we do know. We know 0, negative 2. So 1, 2 right here. That is an actual point. Go ahead and draw that big so you know that's a point there. And again, there are no x-intercepts as well, so nothing touching the x-intercept. So on here, it's kind of like we have two sections again. We have left and right of the vertical asymptote, and then above or below the oblique asymptote. All right, obviously to the left of our vertical asymptote, there is a point staring us in the face. And that point tells us that the graph is somewhere located down here. It's not going to touch the x-intercept. We know that because it doesn't have any x-intercepts. So it looks like our graph is going to be something like this. And above, I can make the same choice, because if it was below our oblique asymptote, it would be somewhere down here. And if it was down here, it would touch the x-intercept like this. And obviously it doesn't. We have no x-intercepts. So let me just hit undo so that I don't have to erase that. So that means that the graph has to be then located up into this section up here, in the other upper part of the x value. And again, it goes between the asymptotes, and it looks something like that. I think rational grammar is pretty cool. I have a great time doing it, and I hope that you will too, especially if you just follow the steps.